So in this video tutorial, I will show you how to utilize StatCrunch for Chapter 6 topics. Let's start with Chapter 6.1 that covers the concepts of standard normal distribution and uniform distribution. Let's start with the uniform distribution. For example, in Chapter 6, there is a question. Statistics professor plans classes so carefully that the length of her classes are uniformly distributed between 47 and 52 minutes. Find the probability that the given class period runs between 51.25 to 51.75 minutes. Let's use StatCrunch. All calculators can be found under Stat, Calculators. This particular calculator is for uniform distribution, so we'll go to Uniform. And then we will need to specify what is our lower limit and upper limit, and we're given that it's 47 minutes and 52 minutes. Now the question asking in between. So we will click on the between button to show the area between the certainty scores. And in this case, it's 51.25 to 51.75. The probability is 0.1. That's what we will put in the answer box, and we need to round to 3 decimal places. You only have 1 decimal place, so we'll add zeros for the other decimal places. Let's go to the next question. Find the area between the two z-scores that are given. Of course, we can use A2 table for the z-scores, but this is not logical because you'll have to do double step. You'll have to find the area that is to the left of the z-score of 1.25, then subtract the area that is from the left of the z-score of negative 0.87. Again, StatCrunch is a great tool to save you time, energy, and effort. Let's go to Stat, Calculators, Normal. And again, we are looking for the area in between the z-scores. So click in between. We don't have to modify mean and standard deviation. Mean is 0, standard deviation is 1 for standard normal distribution. All we need is enter negative 0.87 to 1.25. The area, and we can see it visually shaded under the density curve, is 0.7022. We need to round to 4 decimal places. Great. In this question, we need to find the indicated critical value z of 0.05. That means we're given the area. We need to find the z-score, which is the value on the number line that separates that critical area or significant area from non-significant region. Again, we are going to use normal calculator. Mean is 0, standard deviation 1. Now we're going to enter it in the area field. 0.05, and we need to specify that it's area not to the left, but to the right of the region, right here. Again, we can see it on the graph. That area of 0.05 or 5% of the whole area under the density curve, right here, is separated by the critical value of 1.645. We rounded to 3 decimal places. Now, the next interesting question is asking us to find the area that is between the two z-scores, z negative 2 and z positive 2. We're going to use the same normal distribution calculator. And we will input for the x values negative 2 and positive 2. The area between these two values, we need to round it to 2 decimals, 0.95. We need to write it in the percentages. To convert decimal to percent, multiply by 100, which means moving decimal point 2 times to the right, 95. And we need to round to 2 decimal places, 95.45. We're doing great. Now let's move to Chapter 6.2 concepts. Chapter 6.2 covers the real applications of normal distribution. So for example, in this question, assume that adults have IQ scores that are normally distributed with a mean of 104 and a standard deviation of 25. Find the probability that a randomly selected adult has an IQ greater than 135. Since it says normally distributed, we again use normal calculator. Go to Stat, Calculators, Normal, and we are given the mean is 104, standard deviation is 25. The IQ greater than 135 means that 135 is our X score, 135, and we need to find the probability greater than 145. So we'll change the sign to greater or equal, compute, and round to 4 decimal places, 0.1075. Let's look at the next question. In the next question, we are asking to find the probability that a randomly selected adult has an IQ score between 89 and 129. Again, we are given the mean, it's 105, so we'll need to adjust the mean here in StatCrunch. Standard deviation 20, again, we need to put it in the StatCrunch, and we will use between button to enter the scores of 89 and 121. And don't forget to round to indicated place value. Now, last question is asking about percentiles. Let's read it. Engineers want to design seats in commercial aircraft so that they are wide enough to fit 95% of all males. Accommodating 100% of males would require very wide seats that would be much too expensive. Men have hip breadths that are normally distributed with the mean of 14.2 inches and the standard deviation of 1.1 inches. Find percentile 95. That is, find the hip breadth of men that separates the smallest 95% from the largest 5%. So we're looking for that z-score, right? Now let's see. We have the mean of 14.2 inches. It's not in the middle. We're just looking for specific z-score. So we go to standard, change the mean to 14.2, standard deviation 1.1 inch, and we need to find 95th percentile. So it will be in the area 0.95 to the left. So change the sign to the left. And the z-score, or the score in inches, in this case, is 16.009. We need to round to 1 decimal place. So it's 16.0 inches. And for using StatCrunch for concepts from Chapter 6.4, central limit theorem, I have a separate video that I will send you in Canvas separately. I hope this helps.